customer, whether it is a residential, industrial, or whether it is a HT or LT. These are the 5 important parameters you need to note down when you first see the bill. Then based on this, we can calculate the energy charges, and we can estimate the solar PV capacity, and we can, kind of propose the client whether, how much savings he is going to do, in terms of monetary value, in terms of the units. Yeah. Second thing, it is plant estimation using like available area. So the first thing what we saw was using the electricity bill. Second, using the available area. Like I was saying, the physical activity and physical presence of the surveyor is important over here at the client premises. All the time you won't be getting the client premises as an open area, open rooftop, or open land. So there are some cases, some places where the shadow objects are too high, so you need to do this analysis physically. Like you need to check the orientation of the rooftop, you need to check the latitude of the site, so that the tilt angle of the solar panel can be determined. Analyze the roof type. What I mean by roof type is whether the roof is a RCC, plain RCC roof, whether the roof is a tin shed or anything else. Then the shadow object, like I was discussing, any adjacent buildings, high-rise building or trees or anything else that is obstructing the terrace area. At some cases, there are lift rooms, there are water tanks, which also creates the shadow object on the terrace area. So this things need to be considered. Measure the shadow area, check the distance between the roof and the meter room. These are the physical activities a person needs to, surveyor needs to do when he visits the client place or the proposed terrace area. The distance between the rooftop and where the plant needs to be installed and the meter room is most important, because the distance plays a very important role in voltage drop or the current resistance. Then area of earthing, where you're going to do the earthing. Earthing is very important factor again in solar plants. Accessibility to roof, how you're going to lift the solar panels on the top of the roof, on the terrace, heavy inverters, etc. The structures, very heavy structures, how you're going to take it on the terrace, whether you need to use a crane or you will be having a service lift, etc. And the load bearing capacity of the roof. When I mean to say heavy solar panels, heavy structure, you also need to consider the factor that the building, if it is old, what will be the load bearing capacity of the roof. So these are the parameters that are important when the physical inspection is considered, or the physical site survey is when a person is doing a physical site survey. I hope till now 2 points are clear. One is the plant estimation using electricity bill, what factors you need to consider, and the second is the factors when you do the site survey. Now, how to estimate the solar capacity using area? For example, by doing this above analysis, that is the area analysis, you come to know that there is certain meter square area available on the terrace, or let's say certain square feet of area is available with the customer. Now, how much solar panel you can install in that also describes the capacity of the plant. How you calculate it, we'll do a small example, small exercise. Let's say a 1 kilowatt PV system, that is a 1000 watt peak, considering the solar panel 330 watt peak. So this is a polycrystalline solar panel I have considered here of 330 watt peak of any tier 1 manufacturer, or any manufacturer you can take, depends upon the customer budget. Dimension, we need to understand what is the dimension of a single solar panel. A 330 watt peak solar polycrystalline module will approximately will be of size 2 meter by 1 meter, that is approximately 2 meters square. That is the size of a single solar panel of a 330 watt peak. As you go higher, let's say if you are considering the latest available solar panel of 650 watt peak, that is the maximum available nowadays, it will go up to 2.7 meters square, or up to 3 meters square. That is the size of a single solar panel nowadays available in monocrystalline technology. Coming back to our example, a 330 watt peak single solar panel will be of size 2 meters square. Total solar modules for a 1000 watt peak, that is 1 kilowatt peak, would be, as you can see, 1000 divided by 330 is approximately 3 modules that you need to consider for a 1 kilowatt solar plant. Total area required for a 1 kilowatt solar plant would be 3 module multiplied by 2 meters square. That is the size of a single module, which is approximately 6 meters square. So this is the size of a module area. That is your PV area. Considering, you also need to understand that there must be other spacings required to install that plant. That is the foundation area, the structure area, the interspacing between the module to module, and between the row spacing. So considering all these things, I have taken a simple thumb rule, or you can say a simple estimation based on our experience, that we are taking 2 meters square as an extra space for foundation, module spacing, etc. for a 1 kilowatt plant. So 6 meters square is a complete PV area, and 2 meters square is the additional area for the other things. So considering these two areas, we get a total of 8 meters square for installation of a 1 kilowatt peak system. I hope this is a simple thing that is understood till now. Now, how this is useful in a scalable basis. Let's say you have a customer inquiry, you have a kind of area available with you without visiting. Let's say you can also do that using Google Map also. If time permits, I'll show you how to measure the area using Google Map by sitting in your office. So let's say a terrace area available with the customer is of 100 meters square. So considering you have 8 meters square required for 1 kilowatt peak, you can simply calculate what will be the capacity you can propose to the customer. At sometimes the electricity bill doesn't play a much of a picture, because in open access cases, in that case, you require to have the analysis using the area. So I hope you understood when to use the area analysis, when to use the electricity consumption uses. So in larger scale, in open access, the electricity bill doesn't come into picture, because it's just the installation you need to do, and draw the power and evacuate into the grid or into the substation. There is no electricity bill in between. But in the rooftop systems, or in a small ground mounted system, when captive consumption is there, you need to understand, or you need to do the analysis using electricity bill first, and then using the available area with the customer. Coming to the type of roof that we discussed, so there are types of roofs such as RCC roof, where the load bearing capacity is much higher of the building. Second is a tin shed type roof, where you can install the foundation is kind of not required over here. You can directly use the clamp based the solar structure, aluminum structures over here, which is lightweighted. And then there is carports or sheds available on the direct walkways. So these are the type of roofs which I needed to show. Fine. So this was just a small thing. I hope you have got a fair idea, like how to estimate, what are the ways to estimate the electricity or the solar capacity of any client. One is, again repeating, one is electricity bill analysis. There were 5 parameters that we discussed required to see in the electricity bill to estimate the capacity. Second is using the area. I have given a small example of a 1 kilowatt system, where a 1 kilowatt system requires approximately 8 meters square area. Accordingly, you can do the scalability. Now we'll go much deeper into the electricity bill analysis, that is estimating the solar plant capacity using electricity bill of the customer. Let's consider the customer has ample amount of space is not a constraint over there. So how you will do it using the electricity bill? So I switch the PPT. I'll just close this, and I'll share another slide of PPT where you will be able to see the electricity bill of one of the customers from Madhya Pradesh. Before that, any question till now? Anyone want to raise hand, and anyone want to say anything? You can go ahead.
Sir, we can take question at last of the session. I think it will be better.
Fine, no issues.
Yeah.
Yeah. So, sir, I've shared a screen of one of the PDF of one electricity bill. Is it visible?
No, still your PPT is only visible, not that PDF.
Okay, okay.
I think you should first
Yes,
close
I'll
the
switch.
sharing and reshare it.
Yes, yes, I'll switch that. Kunal, yes, sir. Is it visible now?
Yes, it's visible. Visible.
Okay, okay, fine. Yeah. Yes, sir. Fine. So this is a recent kind of analysis that we are doing currently. So we are about to install a 2 megawatt solar plant for this customer, and we have just recently done the complete DPR preparation and everything. That is a detailed project report, and soon we are going to install a 2 megawatt plant for this customer. Now again that 2 megawatt, yeah. So this 2 megawatt plant is a complete captive consumption because the consumption required for this customer is very huge. So we'll go deeper into that. What are the things that you need to see? So this is from one of the discom, that is MP Paschim Kshetra Vidyut Vitran Limited. That is the discom for Madhya Pradesh. I hope the text is clear, or you need me to zoom it a little bit. Yeah, fine. So yeah. So as you can see, few things that I requested you to note down. One was five things that are important in the electricity bill, five parameters that are important. We'll directly point out that those parameters, and we'll see where are those written in the Madhya Pradesh electricity bill. So first thing is the contract demand. So in some places there are contract demand, and some places it is written as sanction load. When you say contract demand is the demand, what do you mean by contract demand? Contract demand is mentioned over here, as you can see. Yes, I have bolded it over here, highlighted it. It's on the left corner, contract demand. So contract demand is nothing but when a customer takes the supply from the discom. Discom is nothing but a distribution company, which is Vidyut Kshetra Limited. Yeah, MP Paschim Kshetra Vidyut Vitran Limited. So that is the discom for MP. We'll term it as discom from now onwards. So when a customer takes the connection from the discom, they, the energy auditor, they give them some numbers, in terms of power. That number is indication of how much load is connected at the customer premises. Say for example, I have an kind of established an industry or manufacturing unit. So whatever equipments, whatever load I have connected over there, the total power and some additional power for future loads is basically given. The energy auditor gives them that to the discom while purchasing the connection. So for example, the customer over here has demanded for a 1825 kVA connection. That is the contract demand. At some places, it is also mentioned as the sanction load. Over here in MP, it's mentioned as the contract demand. So first and foremost important thing is the contract demand. Now, how it is important? How does it play a picture in deciding the estimated solar PV capacity? It comes, you know, from the policy of the state. Now, each and every state has different policies. In Maharashtra, we have an office in Mumbai. So in Maharashtra, the policy from MERC, that is Maharashtra Energy Regulatory Commission, the policy is that we can install up to 90% of the contract demand mentioned in the electricity bill into solar. That is, if it is a 1000 kVA capacity contract demand, I can install up to 900 kilowatt of solar power plant for that particular bill. Similarly, for Madhya Pradesh, it was earlier 50% of the contract demand. So whatever is the capacity, you can install up to 50% of the contract demand. So that is basically your policy of the state. Moving further, first thing was the, like I said, contract demand. Second is the energy charges. Energy charges is mentioned over here, as you can see. Energy charges is mentioned over here. 7.16 is 7.16 rupees per unit is the energy charges charged for this industrial category. Okay, the category, as I was mentioning, there are three categories: residential, commercial, industrial. This category, this particular customers lies under industrial category. As you can see over here, it's mentioned industrial. Second thing which we saw was the category was whether it is a high voltage connection or the LT connection. So it is a HV connection. Coming to the electricity energy charges, 7.16 is the rupees they are charging per unit for industrial sector over here in this particular region. Sometimes it also varies from region to region, okay, within the state as well. So for them, for this particular customer, it is 7.16 rupees per unit for particular time of the day. I'll come to it. There are two energy charges mentioned over here. One is 7.16 rupees, another is 6.11 rupees. Now, this basically is the time block that you are going to use. The electricity bill, it's not mentioned over here clearly what is the time slot, but I'll just give a brief idea. So the time slot starts from 6 a.m. morning to evening 6 p.m. That is the peak hours, considered as a peak hours, where the tariff will be slightly higher than the regular tariff. Then the second slot starts from evening 6 to 10 p.m. So this particular is the second slot. And the third slot starts from night 10 p.m. to morning 6 p.m. These are the three time slots that are defined and termed as on peak period and off peak period. So during the peak period, the electricity tariff will be slightly higher. During the off peak period, the electricity charges will be lesser. I'll repeat: from morning 6 to evening 6 is the peak hours. From evening 6 to 10 p.m. and then from 10 p.m. to again morning 6 p.m. These are the three time slots that are defined by the discounts. The charges, the tariff varies. How much unit you use in this time slots, the tariff varies accordingly. During the night time, that it is also called as the off peak period, and the charges, the electricity tariff will be lesser. During and in some states, in some discounts, they also give you rebate if you use the electricity tariff during the off peak electricity during the off peak period. I'll come to that rebate portion as we move ahead. So this particular energy charges, that is 7.16, is nothing but your peak hours time electricity consumption. So 6,84,042 units are the consumption by the customer during the peak hours or peak period or peak time of the day. Energy charges, again second term, which is 5423 units, that is 54,723 units during the night time. That is where they are charging lesser by 1 rupee, that is 6.11 rupees per unit. So these are the energy charges, and these are the energy kind of divisions, tariff divisions, that is based on the time of the day. I hope this is clear till now. Yeah, coming to the second thing, the first thing basically is the fixed charges. So the out of the five things that we discussed in the PPT, one thing was also I mentioned was the demand charges or the fixed charges. Fixed charges are something which are not variable and which are not going to reduce even after installation of the solar power plant. So any customer, make this concept very clear to them, because the customer have this misconception that the complete bill is going to get reduced. I just zoom out. As you can see, for this customer, it's almost 10 lakh rupees that are the fixed charges. The customer needs to pay these charges compulsorily, because these are the connection charges that they have taken. So the maximum or the contract demand that they have taken is 1825 kVA. If I'll go here on the left side, as you can see over here, the maximum demand recorded for this particular month, which is the month is nothing but August. As you can see, August 22, billing month is August 2022. For the August month, the maximum demand recorded in the meter is 1140. So 1140 kVA is the power that has been recorded in the meter. All the meters has some multiplication factor, that is the configuration that the meter has. The meter of this particular discom is having a multiplication factor of 1.5. The meters won't be taking huge readings, so they set the multiplication factor 2, so that that can be multiplied easily during the billing or during the analysis, because the meters have some limited space of displaying the numbers. So the multiplication factor is 1.5 is clearly mentioned. The meter number is mentioned over here. This is the meter number of the customer. This is MF is nothing but the multiplication factor. Multiplication factor 1.5. When you multiply 1140 by 1.5, you get 1710 kVA. So 1710 kVA is nothing but your this thing, maximum demand that has been captured in this particular month of August. So I'll just multiply over here. Just a moment. Yeah. So I hope this is particularly visible to all of you. The calculator, I'm just opening the calculator for you so that you can see what I'm calculating. So 1140, when we multiply it by 1140 is when multiplied by 1.5, you get 1710. So 1710 is the unit, sorry, is the maximum demand in kVA that is been recorded or billed. So billing demand is 1710, demand recorded is different thing. So coming over here on the left side, fixed charges. The first and foremost thing in the bifurcation of the bill is fixed charges. In any bill, you will see the fixed charges is the first thing. So 1710 kVA multiplied by 597. What is 597? 597 is the rupees they are charging per kVA for HT. Okay, for high connections. So a three-phase connection. So 597 rupees. Earlier, this is for 2022 bill. Earlier in the year of before COVID, that is 2019, it was something around 560 rupees. So it has increased by 37 rupees in this 2 years time. The fixed charges, energy tariff is obviously has increased, but even the fixed charges has increased by, in this last 2 years, 3 years. So 597 rupees per kVA multiplied by 1710. Let us see whether you are getting it right. Multiplied by 597. Yeah. So you get 121020,870. So this is your fixed charges. These are not variables. Next is energy charges. So the energy charges, like I explained, there are tariffs depending upon the time of the day, the time slots. Off peak period and peak period are the two periods that are considered over here and has variable tariff rates. Coming over here on the left side, again, these are the readings on the left side. On the right side, they are the bifurcation of the billing. So the reading are always taken in units, that is kWh. So if you'll see the reading on 23rd August will always is one, whatever the number is, on 23rd July 2022 will be, is the previous reading. So the total units for this month will be the current reading minus the previous reading. So when you multiply, the difference will be 738765. So when you minus this reading by this reading, you will get this many units as the recorded units in terms of energy. So 7,38,765 units are being consumed by this customer in a month. Fine. So I hope this is clear how where to identify the units. Then next thing is the peak period. So the peak period units is this much. The off peak period units is this much. So the bill, this bill, particular bill, do not have that time breakup, TOD breakup. The TOD breakup, well, like I suggested, the slots will have these units mentioned. So these are the bifurcations of this particular units. There are 2 to 3 slots in some discoms. There are 4 slots also. So the off peak period, any one of the slot will be off peak period, any one of the slot will be majorly the daytime slot will be the peak period. So the peak period is this much, the off peak period is this much. Fine. So this are the bifurcation again for this tariff. So I just add this to particularly these 2 units, that is 684042 54723, and add this and show what it comes to. 684042 plus 54723. Yeah, so it's 738765. So as you can see, 738765. So this is the total units has been bifurcated into 2 particular units at different tariff rates. So these are your energy charges, these are your energy charges, these 2 are the energy charges. Now when you design a solar system, all these components changes based upon your solar consumption generation. So whenever you install solar power plant, this energy charges from grid will reduce. This energy charges might not reduce because that this is a nighttime consumption, because solar is not going to produce anything during the night time. So this might remain same, but there is a heavy scope where you can reduce this particularly this unit. So whenever there is this type of bifurcation, always take the tariff which is during the daytime, sorry, the consumption that is during the daytime. So which consumption we are going to consider for understanding the for calculating the solar power plant is this particular unit, because this is the daytime unit consumption from grid. This is a nighttime. Nighttime we are not going, solar is not going to produce anything. So considering that unit for designing solar PV system will be oversizing of the solar power plant. So oversizing should not be done. Cost increases, everything increases, payback period increases. So that's a loss for the customer. Fine. Coming to the fourth particular thing, that is the FCF. That FCF is nothing but fuel adjustment charges. Fuel adjustment charges are basically the charges that are taken by the discom, where they all the transmission distribution takes place. That adjustment, fuel adjustment charges is basically taken over here. So that charges is nothing but your peak charges, sorry, your unit consumption multiplied by 0.1 rupees, that is the 10 paise. When you multiply, you get this particular amount. Similarly, FCA charges for the off-peak period consumption 54723, that is nothing but multiplied by 10 paise, you will get 5472 rupees. Fine. I hope this till now this is clear. This 10 paise, how you got this 10 paise, it has been determined by the discom, and this is particularly fixed. They there's a slight increment in this over the time, but it's almost this much only. PF incentive. PF is what? What is PF? PF is nothing but power factor. So when a customer has a good power factor close to 1, the discom gives them some incentive. What is that incentive? That incentive is nothing but whatever the total is till now, this total, the amount total, this amount plus this amount plus this amount plus this amount, to take that total, you multiply it by 7%. The 7% is the incentive on the total value is given by the discount. So that value will come in minus, because that much amount will be reduced from your bill. So that's why it has come written into minus. So how this value got? You got this value 5305974 is the total of this value plus this value plus this value plus this value. When you total all this, you get 5305974 and take 7% of it as an incentive, power sector incentive. You get this much amount will be rebated from your bill. Fine. The taxes, the electricity duty, they call it as electricity duty, that is the taxes. You are getting a taxes of approximately 9%. Now, what is this? What these taxes are? These taxes are basically kind of the duty, the import duty that is being charged for the coals and everything. So some part of it, they take it from us, from the customers. So the duty is 9%. This is again standard, and also standard for industrial may vary from category to category. For residential, it might be different. For commercial, it might be different. So don't get confused. If you see your own house bill, might not have this particular things, because this is for the industrial category and the most difficult category, I would say. Okay, fine. So your total consumption, total units that you have consumed in this month is 738,765. That is 7,38,765. You take 9% of it, and you will get this particular amount. Fine. Again, now the next thing, TOD. TOD is nothing but time of the day. Time of the day rebate is basically when, like I was saying, when you use during the off-peak period, when you use some particular consumption, when you do the consumption during the night time, you get some amount as a rebate. So 25 is the off-peak period reading. So that is nothing but 2,55,657,675 units consumed during the night time. You get rebate on it. So rebate is this much, and you get this amount in the term of minus. Fine. Rebate on online payment, government. Hello. Yeah, is there any question from someone? I got some disturbance. Anyone wants to ask? Anyone
No,
trying
sir.
to ask something?
Please carry on, sir.
Yes, yes. Sure. Thank you. So rebate on online payment. So like government has been, kind of promoting the digital payments and everything, digitization. So payment done online, get some rebate. So 1,000 rupees is the policy that they have made, where you get rebate of 1,000 rupees if you do the payment online. Fine. Rebate at 1 rupees on incremental units. What is this? So rebate at rupees 1 on incremental units is nothing but government actually provides a rebate when you you cross the consumption beyond some threshold value. Now, what is this threshold value? They take your 3 years total consumption, average it out monthly. For example, they take 12 last 36 months total unit consumption, they take an average of it, and that average, monthly average, if you have, they will set it as the threshold. When your consumption for this particular month goes beyond the threshold, they give you 1 rupees per unit as a rebate. So this is a very good policy that they have given. So, and obviously they also trying to encourage people to use more and more units basically through this. So 1 rupees will be the rebate that they give. So this many units are the extra units in this month beyond the threshold. This shows also the demand, kind of the demand from the customer has been increasing this much. So this much is the rebate that you will get, and finally all this totaling, that will be the total bill of the customer. So I hope till now everything is clear. If there are any question, like ma'am suggested, at the end we will take it up. So now these are the parameters that are important to understand in this in the electricity bill. Till now we have not reached into solar, how to do it using solar. So I'll come to it. Now I will the most important thing, like I said, first will be the energy. What is the energy consumption? So the energy consumption over here is 684042 and 54723. These are the two energy consumptions divisions. So I was suggesting night time we are not going to consider, we are going to consider 684042 as the total energy consumption for us, okay, for this particular customer. So I have made a small Excel actually. Basically, that Excel is just a kind of, you need to put the entry, and then you will get the total electricity capacity estimated. So I'll open that Excel for you and try to display that so that you can understand it in a better way. Yeah, fine. So this is the Excel that is used to kind of, that I use to estimate the total consumption or the total solar power estimation, capacity estimation. So I will first show what exactly this is. The first thing in this Excel is, just give me 1 minute. I think the Excel is not able to be viewed. Hello. Yeah. So there is some problem with the Excel. It's taking much time to load actually.
No issues, sir. No issues.
Yeah, yeah, yes, yes, yes.
No.
So basically what I was trying to explain is we need to take the electricity, yeah, whatever the electricity consumption is there, we need to take that consumption And yeah, so this particular 684042 is the total consumption. I'll just make it simple in the calculator rather than till the time our Excel gets loaded. So yeah, so 684042 is the total consumption, energy consumption. This is the monthly consumption, so simply divide it by 30, so you get the total daily consumption. So I'll divide it by 30. So you get 22,801 as the monthly daily consumption. So this is your daily electricity energy consumption from grid. I hope this is clear how you got to 22,801. We just divided the total monthly consumption by 30 days. You get the daily consumption. Now, when you have studied the solar PV concepts, you must have understood what is the average radiation that India gets per meter square per day. So that is nothing but 4 kWh, that is the 4 hours of radiation or 5 hours of radiation in some good areas. But the average radiation that India gets is 4 hours, or you can say the peak sunshine hours in a regular term is peak sunshine hours. So PSH for India is 4. So when we take the average, we are taking 4 as the thumb rule, which is the PSH. So divide per day, that is per day. Peak sunshine hours per day is 4 hours. So when you divide 22 hours, 22,801 by 4, so divided by 4 hours. So this is nothing but your 5700 is nothing but your wet peak. Earlier 22,801 was your kWh. So kWh divided by 4h, 4 hours. So the hours get cancelled. Your unit, basically the figure from energy, it gets converted to power. So 5700 is the total power or the capacity of the solar power plant. That is nothing but 5.7 megawatt. I can say 5.7 megawatt is the total power capacity of the solar power plant that needs to be installed. So I hope this till now this is clear how to figure out the total power total PV capacity, that is the power capacity of the solar power plant. So for this particular customer whose consumption is approximately 6,84,000 units per month, which came down to 22,000 units per day. Through that we finalized 5.7 megawatt as the total capacity of the solar power. So I hope this is till now is clear. So I take one more example. This was a detailed study of one particular bill. I'll give a small example of another bill. We will quickly see that bill and see how you can relate this bill reading with that particular bill reading. ये फोल्डर ही है
Share one of the slides. Hello, Devul sir. Hello, hello.
Yes, ma'am.
Yes, sir. Sir, you are not audible actually.
Acha, acha. Okay, I was not audible.
Yeah,
Just a minute.
yeah.
So, is the Excel visible now?
It's visible, sir.
Okay, okay. Excel is visible now. Fine.
Yeah,
So, yeah, I'll come to the Excel now.
yeah.
Yeah.
Sir, initially also what you have explained that we could not able to
I'll
hear
show
due
that.
to
Yeah,
COVID.
yeah. I will come to that
Yeah,
again. Yes, yes,
yes.
sure. So in this Excel, as you can see, what I have done is I have divided this. I have made a table where I have shown monthly consumption, January, February, March, April, up to December. So what you have to do whenever you get a bill, let's say this bill over here, I was saying in this bill is always take the average of the annual consumption. If the customer is having, let's say, a bill where all the 12 months consumption are mentioned, as you can see over here, then it's good. You can do your work through a single bill also. But in cases like we saw in that Madhya Pradesh bill, there was no such table where it was showing the 12 months consumption. So in that particular case, you need to take 12 bills from the customer, all 12 months bill. 1 year bill you need to take. You take all the 12 months bill. This is the units that will be mentioned. So I'll come to the units. You need to put these units over here. So why I am putting this different rows over here is because when you go to a residential society, they have multiple meters. They have 1 meter for the common wing. They have 1 meter for the water pump. They have 1 meter for fire extinguisher, one for the lift. So that's why you need to take all the total bills. So that's why I made different column rows over here. I will just delete all this because over here we have single meter. Let's assume the customer is having a single meter. If the customer is having multiple meter, take all the total and then take the average. So over here, the single bill, I will just write it. Fine. And I will take the single consumption. Let's start it from January 28072. So 28072 is the total unit for January. February, it is 24238. As you can see here, 24238. 24238. Similarly, you need to type everything over here. 25845, 25845. Then April, it is 29000. These are the unit consumption from the customer. Then May 30474, 30474. This is your May consumption. Then June 31929, 31929. July, it is 35416, 35416. August, it is down over here, 25177, 25177. September, it is 24827, 24827. October, it is 36451. 36451. October, November it is 23234. 23234. And December last it is 24951. 24951. Yeah. So I'm again repeating, just in case the customer do not have this table in his bill, on the back side or the front side, ask him for 12 months bill, but take the average over the year. That will be more optimized design. Don't take a single bill and just do the calculation based on that single bill, because the value might differ over the average. Because during the sun, the solar power plant, consumption generation also we take average over the year. So the consumption from the grid also should be taken average over the year. So what is the average I am getting over here? I am just have to enter the values. I will get the average. The average is 28,301 units. That is, I directly got the PV plant capacity. As you can see over here, it's 230 kilowatt. How I got it? I'll just show. So once you got 28,301 as the total average capacity consumption, monthly consumption, just do simple calculation that we did, divide it by 30. So what I'm doing over here is, you can see I have made a simple formula. Take the total value, average value 28,301, divide it by B16. What is B16? B16 is your nothing but number of days. So number of days I have mentioned over here. Number of days is 30.4. That is average of 365 divided by monthly days. So it's not 30 or not 31, it's 30.4. That is the average day in a month, days in a month over the year. So divide it by 30.4, then divide it by D16. What is D16? D16 is 4.05. Now what is this? This is your PV generation per kilowatt per day. Per kilowatt per day, or I can say peak sunshine hours, or I can say the radiation falling in India per meter square per day. So this is 4.05. This data you can get it from Meteonom software or from NASA website also. For any latitude, longitude, you can get this value. The radiation of sun over that area per meter square, that is what your PSH over the day average it is. So 4.05 for Madhya Pradesh is good enough, for Maharashtra is good enough, for Rajasthan, for Gujarat, it might go up to 4.5. But to be on the safer side, we will not over, become over ambitious over here and take higher value of the sunshine, because there are other things, other factors you need to consider, like monsoon and everything. Though this is average, but we will take always little bit on the lower side. So the thumb rule is always take it 4. So when you take it divided by 4, you simply get the total capacity of the solar power plant. 230 kilowatt is the total capacity for this particular bill. Okay. Now this particular bill has a contract demand of 700 kVA. So I am 230 kilowatt solar plant is also fulfilling your total contract demand policy. The total contract demand policy in Maharashtra, this is a Maharashtra State Electricity Distribution Board. For them, we are doing this now. So for Maharashtra, it is 90% that generally the EPC players do the calculation with. 90% of the contract demand is maximum allowed. So 700 ka 90%, I will take 700 into 0.09 is approximately, 700 into 0.9 is approximately 630 kilowatt is maximum allowed over here. But based on the consumption, we are getting much lesser than that. It means we are within the range of the contract demand policy. 230 kilowatt is what is going to be proposed to this customer. Coming to the units generation. Now a 230 kilowatt unit plant, how much will be the generation? How to do that? Simple. Take the annual monthly data from January to December. As you can see over here, I'll just zoom it. Yeah. So from January to December, write all the months, number of days in that month, radiation. This is the radiation that you will get from Meteonom software. You can do this homework. You can go and download the Meteonom software. There is no much R&D required over here. When you install the Meteonom software in your computer, Meteonom, you just have to type the latitude, longitude of the area where you want the radiation data. take the global horizon data. Global horizon radiation is nothing but your solar power radiation, solar sun radiation data. So when you take this over the day, so when you take this, you get this data which is on the higher side. But after taking some generation losses, you know solar power plant, you take approximately 25% as the radiation loss. So that after taking that radiation loss, it get reduced to 5, from 5.39 it get reduced to 4.05. So this is the average radiation that we take. Again, I'm saying per kilowatt per day, or you can say this much is the radiation per unit per hour per day. Okay, so when you simply multiply this data with, I can show you the formula, multiply 31 multiply by this particular data 4.13, that is the radiation per kilowatt, and multiply by u15. U15 is nothing but your 230 kilowatt. So you get this much is the generation from solar power plant. So what I have done is I've taken the estimation from electricity bill. I have taken 230 kilo, I have estimated 230 kilowatt. From 230 kilowatt, now I am estimating the generation from solar. So this is the radiation data. Through radiation data, I am estimating the generation. So when I take the annual generation, I get approximately 3,39,088 units of generation from solar power. As see the graph, I also made the graph over here. This is the consumption, red color, from electricity board, that is from DISCOM. The blue color is the radiation. Through the radiation, that is we have estimated the generation. The generation approximately this much. And when I compare it, as you can see, the red color is nothing but your electricity consumption. Blue color is your solar generation. So consumption versus solar generation is almost neck to neck, except in the month of June, July, August, where the rainy season are more. So this is June, July, August. So this is June, July, August, where the radiation is less, the generation is less. But in, as you can see, in February, January, February, March, April, and May, you get the maximum generation. The blue color lines are higher than that. The March is the month that produces the most solar radiations. So it's not April or May, but the solar power, solar plant generates more in the March month, because the temperature is also under control and the radiations are also good. In April, May, the temperature increases, and the increase in temperature is nothing but you get the temperature coefficient loss factor comes into picture. So considering all this, as you can see, when you take it out, take the average, you get approximately this much units of generation, what we have been calculating in the monthly. So as you can see, the electricity bill, again coming to electricity bill, it was approximately 3,39,000 is the consumption from the electricity bill. The data that we entered over here, the monthly data, you got 3,39,000 is the total annual. From generation also you get almost 339. It means 100% energy saving over here in this bill. Okay, coming to that particular bill, Madhya Pradesh bill, I'll come to that, and I'll just then we'll close it. In this bill, you have total contract demand as 1825 kVA only. So this is the maximum you can install over here. The consumption demands more than that, but the because of the contract demand policy, you cannot install 5 megawatt over here. Okay, so that is the problem. Or you need to, what is the solution you can give to the customer? The customer can increase this, he can give the application and increase his contract demand and then go for solar. So this is the kind of suggestion that you can give to the customer. So I hope through this electricity bills, and you will be able to estimate the PV plant capacity for any customer. I hope this is true for you people right now. And then once you install the solar, once you determine the PV plant capacity, then you have to go to your back to the basics, that is whether you want to go for on-grid system or off-grid system. Generally this is for on-grid system. Then in the on-grid system, which panel you will take, how many panels you will take, and what will be the string combination, what will be the inverter that you select, what will be the ACDB or DCDB that you are going to select, and all this stuff. the cable sizing and everything comes into the more detailed designing of the PV system. So that's a complete different topic that I hope, I mean, that is also covered at some stage later, maybe next time. But I hope till now you have understood how to estimate the plant capacity based on the electricity bill, based on the area. So I think that's it from my side. I have a small presentation on, what are the execution steps. So the execution step, we'll just quickly have a look at it. Uh, this is the final topic that we have. So once you have determined a 230 kilowatt solar power plant or 5.7 megawatt of solar power plant, what are the execution steps that you need to carry while installation? So execution strategy and installation steps. So first is design and engineering. A small part of designing, that engineering in design we have done, that is the estimation. Second, similarly, you need to, like I was saying, the capacity estimate. Once the capacity estimation is done, then you need to go to the plant, this thing, panel selection, solar panel selection, layout, string combination, etc., etc. So that comes into the engineering part, design and engineering part. So area analysis is done, and once the area analysis is done, the plant layout comes into picture. Plant layout means how many solar panels into parallel, into series, and all those stuff. What is the orientation of the solar panel? What is the tilt angle of the solar panel, etc. Electrical layout is nothing but the ACDB, the DCDB, the combination boards, etc. The component specification, the best component, the best efficiency you need to select. BOS items is nothing but the cable selection, the earthing, lightning arrestor protection, surge protection devices, etc., etc. So this comes into the balance of system items. So once all this design and engineering is done, you need to go for procurement. Procurement of modules and inverters are the most important thing, because 70% of the procurement is, 70% from the procurement comes into is through your module and inverter, and the most costly ones, then modules and the inverters. Then installation, first structures, then module, then inverter and BOS items. So these are the steps. And then finally the testing. Testing is again the most important aspect. Mechanical testing and electrical testing. So mechanical testing is nothing but your physical checks, the tightening, screwing, everything. Electrical testing is your leakages, the current leakages or any wiring faults, etc. Commissioning. Final commissioning is nothing but the termination of the AC cable to the end LT panel or the grid. So let's say this is the available area, this is the terrace area. So first you need to do is the CAD designing. Once you are done with the CAD designing, these are the tables that we have formed, and this is a complete CAD designing. A AutoCAD designer needs to do this. Installation steps. This is a clear ground. Let's say this is a clear ground. These are the foundation blocks that you have casted based on your CAD design. You erect the column. So these are the columns. So this is the side view basically. Assume this, imagine this as a side view of the solar plant. So once this is the columns are installed, they are always at a tilt. So the front column will always be at a lesser height. The back column will always be at a higher height. So that you can get a slope towards the south facing, or generally the outer side. So this is the rafter that you need to install. The rafter is a part of the structure. After rafter, you can install the purlins. So this is a C-section purlins that you need to install perpendicular to the rafter. This is a side view, so you can just see the C-section in it. And then the solar modules. So on the purlin, you need to install the solar panels. So these are the solar panels. So these are the solar panels that are installed. This is a stack of 3. 1, 2, 3. 3 solar panel installed top of each other. So this is a stack called as a stack of 3. Okay, so this are the physical actual site view images. So first you need to do the marking. without marking you cannot install the you cannot cast the solar foundations. So if the foundation goes wrong, everything goes wrong. Your designing, everything will get become faulty. So foundation, before foundation casting, proper marking, proper alignment is very important. Use line dori etc for doing that. Okay, so once your marking is done, once you need to do the grinding. Grinding is nothing but you need to rough the surface. If it is this much, plain, you need to rough it little bit. So you're using a grinder so that your foundations, it will get casted properly. It will hold the rough surface properly, because your customer will not allow you to make a drill hole over there so that you can do the anchoring. Because of the leakage issues, every customer will say that I will not allow the leakages problem to occur. So roughing this much is also okay. Then you can cast the foundation. So foundation casting. So what is this? This is nothing but your concrete rebar cage. It is made of MS generally. So generally there are four these things, bolts, J bolts, I would say J bolt, that are being made. A cage is made. You need to put it on in the template, and you need to cast the foundation like this. So on these four particular holes, bolts, you can directly place the column, base plate, and install it. So this is the direct column base plate, and it being installed over the like this. So these are the columns, vertical columns. So as you can see, the back column is at a greater higher height, and the front is a lower height, so that you get the slope properly. So as you can see over here, the once that is done, you need to install the rafter, the purlin, and the solar panel like this. So this is called as one row, second row, and so on. So this is the complete solar plant that has been installed now. So this is not at a greater height. This is a very lower height at the terrace level. Okay. Once this solar panel is installed, you need to do the proper structure earthing to avoid the leakage current go to the ground. This is the electrode. You need to put it at least as per MNRE, it is 3 meter deep and 3 meter apart from one another. So that is the electrode of the earthing, module interconnection, and then proper cabling. This type of cabling is not allowed where all the cables are hanging. You need to use proper conduits or any particular mechanism where these cables will not hang like this. Then cable routing up to the inverter. So once this stringing and everything is done, you need to take all this cable through the conduit and take it to the inverter and do proper marking, because during the maintenance, if this plant has to be maintained for 25 years, if you don't do the proper marking through ferrules, this yellow color are called ferrules. If you don't do the proper marking through ferrules, you will not be able to identify which string has which panels and which particular cable is for which string. So this ferrule is very important while doing the connection. And output from the string connector strings goes to the inverter, and then inverter, through the inverter, it's converted into AC. So for example, if you have 230 kilowatt plant or 1 megawatt plant, you will take 200 watt peak string inverters, 5 numbers for a 1 megawatt plant. Let's say it is a 230, so I will take around 150. So I get 250 of watt peak of kVA solar inverter. So I have inverters over here. All the AC output from the inverter are combined through AC cable into the LT panel. So from inverter, it goes to the LT panel. Also, not the LT panel, but the ACDB. ACDB is the combiner box. So all the AC output from the inverters goes to the ACDB, and from the ACDB, it goes to your NT panel or to the grid. So this is the overall connection topology of a solar power plant, or the execution steps that you need to follow. Testing, and then finally like I was saying, mechanical testing, electrical testing, do it, and then you can see the energy generation. So energy generation, generally it comes in terms of day, month, year, and total till now. So this is the overall execution that you need to do. So I guess I think we have covered. I'll just make a final summary. So we have covered the PV plant capacity estimation, two particular prospects. One is through electricity bill, second is through area. So we have seen how to do it using area briefly, and in detail we have seen how to do it using the electricity bill. So we have seen each and every parameters in the electricity bill what all parameters are there, what all parameters are important to estimate the capacity of solar plant. And then we have seen one Excel where you need to input all the monthly data, consumption data from the grid, and then you get the average out, and then average out you need to divide it with some numbers, with the month, number of days in the month, and divide it by the PSH. PSH is the peak sunshine hours, and then you get the total plant capacity. In one of our example, we got 230 kilowatt. That is the total plant capacity that you need to install. Then we saw the total the execution steps, how to go about the plant execution. So once you are done with the estimation, that's say 230 kilowatt, then how to go about it, the designing, procurement, commissioning, and installation, and then commissioning. So we have seen it through some pictures as well to get a better idea. So that's it from my side till now. I would try. I would be happy if there are any questions or any doubts, queries that you need to ask me. I'll be happy to answer them. Yes.
Thank you very much, sir. It was a very nice presentation that make everything clear about the solar power plant generation. So I just want to ask one thing: if there is any um, restrictions for the spacing of the sun, at least that is our house is north facing or east facing or west facing somewhere. One of my friends has told me that they have gone for that solar power plant, but they have told me it's very difficult because there are some buildings are there nearby the
So
houses that also.
yes. So
What
this
are the
is
restrictions that?
yes. So ma'am, basically that comes into the plant orientation topics. So where a few things you need to take care. One is the south facing. The south facing has to be clear, because India is a northern hemisphere. The solar plant has to be always facing the southern hemisphere, because the sun will always come visible from the south. So south facing is the orientation that has to be followed everywhere in India. The tilt angle of the solar panel is depends upon the latitude of the location, so that the rays fall perpendicular on the solar panel. Sometimes it's not possible to maintain that tilt angle. So in that case, you can put it flat also with the tilt of the roof, but south facing is the most important. If you face it towards east, you will not get any electricity during the evening time. अगर आप साउथ फेसिंग नहीं रखेंगे, लेट्स से इफ यू पुट इट वेस्ट फेसिंग, तो मॉर्निंग में जनरेशन नहीं आएगा. So south facing is the ideal orientation of the solar plant, and it's mandatory. Yes.
So if
Anything?
there are any buildings which are long buildings are nearby, so there is no issue for that.
Yes. So if there are any higher, high-rise building facing towards the south, then you need to do the analysis throughout the day, during which time of the day and till up to what particular line the shadow is coming on the terrace. You need to check that. You need to do that marking, and beyond that point, you need to install the solar plant. You cannot install the solar plant in the area, because आप देख नहीं पाओगे, मॉर्निंग में शेडो नहीं आएगा, because east से sun आ रहा है. So morning में your plant terrace will get the complete sunlight, but during the south afternoon time when the sunlight is more intense, तो वो time पे we don't want any losses. वो time पे आपकी south facing building जो है वो shadow करेगी, it will be on the terrace. तो वो time पे आपको mark करना होगा कि up to what line that shadow is coming. तो वहां पे आप plant install नहीं कर सकते. Or the other thing is, if possible, you can go at a elevated structure, but वो elevated structure high tower के लिए तो काम नहीं आएगा. So if there is a small tree or something which you cannot cut down, so in that case you can go up to 2-meter height structure. Yes.
Thank you very much, sir. Any other query from the participant side? Sir, one more thing, sir, how much it will cost for that? It will depend upon the size of the house, or it is independent from that?
Yeah, so it depends upon the capacity. Like I was saying, the solar plant generally it's depend upon the scalability. So up to I would say 10-15 kilowatt or 50 kilowatt, it costs around 55,000 per kilowatt. So a 10 kilowatt plant will cost around 5.5 lakh rupees. But for a 100 kilowatt solar power plant, it may go to 5 lakh per kilowatt. Sorry, 50,000 per kilowatt. It means 50 lakh for a 100 kilowatt plant. So it varies from 50,000 to 55,000 per kilowatt. In simple words.
Okay, for a simple house, if you want to go for that, it is around 5 lakh rupees. We can
No. So simple house, you will not require 10 kilowatt. You will require around 5 kilowatt or 3 kilowatt, 3 to 5 kilowatt. So it will cost around 2 lakh to 2.5 lakh. Yeah, because house में मैम बहुत ज्यादा consumption होता नहीं है. Equipments भी बहुत high rated नहीं होते हैं. So आपका consumption 5 किलोवाट के आसपास ही रहेगा, उससे ज्यादा नहीं रहेगा. So 5 kilowatt multiplied by 50,000, approximately 2.5 lakh rupees. Yes.
Then in that we get subsidy also, or it's subsidized?
Yes. Subsidy is there for residential, but not for the commercial industrial. That too, Madhya Pradesh में अभी subsidy नहीं मिल रही है शायद, because the subsidies are more inclined towards the farmers now.
Okay.
अगर farmer solar pump लगा रहे हैं तो farmers को subsidy 90% मिल रही है वहाँ पे under Kusum Yojana. Yes.
There is no more queries towards the participant side. So on behalf of Shri Vaishnav Vidyapit Vishwavidyalaya, I am very thankful to Mr. Mehul Patel for deliberating such a nice presentation and make everything clear. Because this solar panels and all these things fascinate. Everyone wants that it's good. We know that it's good we should install, but there are some restrictions. Again, there are it may damage our house roof, or it may damage it will not work properly. Then what will we do? So that you have cleared all our doubts on this.
Yes, and one more thing, ma'am. One more thing I would like to add is, I would be happy ki at least the participant who have attended this, or the recording that is going to go to the participant, people should at least be able to, at least attend the query from a customer. Let's say if they go somewhere and they see electricity bills, they should be able to at least estimate, okay, आपके यहाँ पे इतना solar plant लगेगा और उसको इतना area लगेगा. So designing and installation is a different thing, but estimation and proper estimation firstly is very important.
Thank you very much, sir. And I'll call you once again tomorrow. I'll talk to you for the valedictory sessions, and we are thankful for you also for collaborating in this faculty development program.
Thank you, ma'am. Thank you. Honored. Thank you.
Yeah. Thank you very much, sir.
Thank you, Marias, ma'am.
Yeah. Thank you, sir. And
thank you, participants.
All the participants for attending the session. And this FDP, the 4 days over today. So tomorrow is the last day for the FDP. And morning 10:30 a.m. will be with our next one. So all of you please join on time at 10:30. Thank you very much, sir. Thank you very much, sir.
Yeah. Thank you.
Thank you.